Hello everyone, my name is Neha, and in this lecture I'm going to teach you general troubleshooting of electronic circuits. So there are some steps in troubleshooting electronic circuits which we will see in this lecture, but before that I'm going to first describe the definition of the troubleshooting. So the troubleshooting, it is a method used to track, locate, and correct the most common issues that arise in an electrical circuits, which results in malfunctioning of the circuit. And by another definition, we can say that troubleshooting is a procedure that decides the cause of the issue in electrical circuit by inspecting the affected area and then taking corrective actions. So when you're dealing with a small issue, then troubleshooting takes a little understanding of the circuit and its parts. So it involves the testing of the connections, but overall, you need to remember that if there is any issue in the electronic circuit, then you should have the understanding of the circuit operation and the manner in which different troubleshooting techniques are used. So moving forward, the first rule of troubleshooting is that do not harm yourself. That's the super important rule in troubleshooting. You should make sure that your safety is most important, and you troubleshoot the circuit in such a way that you do not harm yourself. So that's the first rule to keep in mind. Now, moving forward, so we have a couple of definitions in this lecture before we move on to the main steps of troubleshooting. So we're going to see those definition, and these are very basic terms in troubleshooting, and we need to understand the difference and their definition. For example, the definition of fault versus symptoms. And fault is something that is an actual problem, and the symptom is how the problem is visible. So, for example, a cold, a virus is the fault, and a runny nose or sore throat are the symptoms. And you can take another example like a gas leak. So, what would be the symptom? The symptom would be the smell of the gas. That would be the symptom. And what would be the fault? The fault could be open gas knob or any internal leak in the gas pipe. So yeah, it is important to understand what are the symptoms, and in electronic circuits also we can actually see. Sometimes we visibly see those symptoms. Sometimes we can smell it. So we need to understand that and then see what is actually the fault is. Next, we have intermittent fault, and these faults they comes and goes, and they can be influenced by an outside problem. And these intermittent fault, they are also called malfunction of a device or system that occurs at interval, usually irregular. And if an electrical component it has failed, if any electrical component in the circuit has failed, or if there is any open circuit or short circuit in the electronics circuit, then you can find it fairly quickly because it isn't hiding from you. It's a persistent fault that can be isolated by a systematic process of elimination. But when it's about intermittent fault, then it is like chasing a ghost. So 1 minute the fault appears, the next minute it vanishes into air. So problem with this intermittent fault, it basically occurs at random interval, and it's really hard to find intermittent faults. And if you can't actually get the fault to appear, intermittent fault to appear for a long time, then you can't actually fix it. So it's really hard to find this type of fault. Now, next is fix versus repair. The repair is to bring the device system back to its intended operation condition. So, for example, you you basically repaired something was broken and you repaired it, and now it's in its operation condition, back to what it is supposed to do. And a fix is something you can do to work around a problem, like you just fixed it, but that's not a certain solution. For example, if the wires are broken in an electronic circuit, then you somehow fixed it by soldering it, but there would be a chances that in future that it can it can break, because you fixed it for that particular time, and it's the connection is not that strong. So here example is given. You can get your CAD fixed to solve a problem, but you are not really repairing the CAD by doing this. So I hope you understand the difference, and let's move on. Precision versus accuracy. uh, so precision is in terms of definition. If you have a set of measurements, then your precision is the closeness of the measurements to each other, whereas the accuracy is the closeness of the measurements to a specific value. So as you can see, in this case, these are our measurements. So all these black dots you see, these are our measurements, and this red dot is our target. And so we can say in this case, this black dot is, or this black measurements, all these measurements is pretty close to the target. So that's why we say it is accurate but not precision, because precision is the closeness of the measurements, and if you see all these measurements, they are quite spread apart and they are not close to each other. Whereas here, precise but not accurate. Precise, why? Because all these different measurements, these are close but they are not accurate. Okay. And in this case, the measurements, or in your case, in electronics, we can say our readings, they are quite spread apart. They are not close to each other, and they are also not close to the target value which we want to achieve. And in this fourth example, all the measurements, they are accurate, they are close to the target, and all the readings which has been taken, they are precise as well. So the reason why I'm covering this, because you need to understand, if you, when you troubleshoot, sometimes you take the readings multiple times, and you need to understand the readings which are coming, how close they are each to each other, and are they close to the target value or not. So you need to understand that. So if it is close to the target, then you can say that, yeah, your measurements are pretty accurate. But if it is not close to the target and the measurements you're getting the same readings after multiple trial, then you can say the precision is good, but the accuracy is bad. And if you reach to the target and the readings are close, then you will say precision. It has the readings are precise as well as they are accurate. So now we are going to switch to the steps for troubleshooting a circuits. So there are 8 steps. First is the background, then tools, then primary test equipment, power, performance versus specifications, localization, replacement, check performance versus specification. So these are the 8 steps in troubleshooting the electronic circuits, and we are going to get in detail of each of them. And let's see the next slide. So these are the same 8 steps, and you need to remember that these steps doesn't have to be sequential. You can sometimes like go back and evaluate the previous steps, but overall you should stick to this plan and then follow all these steps which I have mentioned here. But sometimes you can if you think that you are not getting the correct results from the previous step, then you shouldn't move forward. You should first evaluate that and then move forward. So that's the same thing mentioned here: adaptable, be flexible, but stick to this plan that you should follow all these steps. Okay. And also, you need to remember that you are not stuck in this loop. So troubleshoot your troubleshooting if you are not making progress. Sometimes when you troubleshoot and you make mistakes, so make sure you're following the right steps in your troubleshooting process, and then you just keep checking to get the correct result. So definition of insanity: doing the same thing over and over again and expecting different results. So yeah, make sure that if you are getting different results in any of these steps, then troubleshoot that why you are getting different results, and see what is going wrong there. Now, all these steps, background tools, and primary test equipment, and further, I'm going to cover in the next lecture. So this is all for today. All just remember these are the 8 steps, and we are going to see what's next there in these troubleshooting steps. So thank you so much for watching the lecture.